Here we'll discuss diagonal asymptotes. You'll find a diagonal asymptote in a rational function anytime the power on top is 1 higher than the power on the bottom. If the power is more than 1 degree higher, you'll get something completely different called an oblique asymptote, which is beyond the scope of Math 171. Also note that if you have a diagonal asymptote, for the purposes of Math 171, you will not have a horizontal asymptote. In order to find the diagonal asymptote, we first must verify the powers, and we'll see in this function our leading term is 2x to the third power. On the bottom, our leading term is x squared. Therefore, we have a difference of 1 power, with the top being higher by 1 power. And that means we need to check for a diagonal asymptote. To find a diagonal asymptote, we'll begin by doing long division. We'll draw a division symbol. Whatever's on top of the fraction will go inside, whatever's on the bottom will go to the left. Therefore, we'll say 2x to the third plus 12x plus 10. Notice we have a missing term. Anytime you have a missing term, like this x squared that we do not see here, we will say 0x squared to fill in the empty space. I will place plus 0x squared in red to show that it is a missing term. We'll write on the left x squared minus 3x minus 4. We'll begin by dividing the leading terms, the 2x to the third inside over the x squared outside. If we take 2x to the third over x squared and we divide, 2 over 1 gives us 2, and x third over x squared gives us just x. This will give us 2x, and then we'll multiply that 2x times each of the terms on the left. We'll take the 2x times the x squared and get 2x to the third. We'll take the 2x times the negative 3x and then get negative 6x squared, and the 2x times negative 4 gives negative 8x. But then we will change all of the signs. The negatives become positives and the positives become negatives. Then we'll combine any like terms we have. The 2x to the third minus 2x to the third cancels and gives us 0. 0x squared plus 6x squared gives 6x squared, and then 12x plus 8x gives us 20x. We now bring down the 10, and we continue the process. Now again we look to the leading terms. We'll have 6x squared inside and x squared outside. If we take 6x squared over x squared, we'll get just 6 because the x squares will cancel out, and we'll write plus 6 after the 2x. Now we'll take that 6 times each of the 3 terms. 6 times x squared gives 6x squared, 6 times negative 3 gives negative 18x, and 6 times negative 4 gives negative 24. Once again, we change all our signs. The positives become negative, and the negatives become positive. Then we combine the terms. We'll have 6x squared minus 6x squared cancels and gives us 0. 20x plus 18x gives 38x, and then 10 plus 24 gives 36. If we try to divide again, we may notice that inside we have only first power, 38x, and on the outside we still have second power. This means our 38x is too low of a power to divide by x squared. This means it's okay to stop at this point and look at our quotient. Our quotient is 2x plus 6. Therefore, our diagonal asymptote will be y equals 2x plus 6. This is how we find the diagonal asymptote of a rational function.